Alright guys, for today's lesson we're actually going to jump over to Module 3 and we are going to look at Lesson 6. So we are proving angle relationships. Before we learned about the different angle relationships, and now we're going to use those to complete proofs. And we'll talk a little bit about what proofs exactly are. But let's look at today's goals. Today we need to prove theorems about angles using the angle addition postulate. Prove theorems about angles by using properties and theorems of angle congruence, and also prove theorems about right angles, okay? So over to the side, guys, let's talk about what exactly a proof is. So just anywhere in your textbook, okay, a proof is exactly what it sounds. You are gathering evidence, aka proving something to be true. So a proof, you could say, would be a collection of evidence proving something to be true. Okay. And so if we look down at the learn here, it says learn the angle addition, and then we have a list of different what we call postulates. So we have a protractor postulate, the angle addition postulate, and then a couple more, okay? So we talked about what proofs are. Postulates we use in proofs, and what a postulate is, that is something that we just accept to be true without proof. So we don't need to prove anything to be true. It's just something that we automatically accept, okay? So truth without proof. So for example, if we look here, the first postulate that we look at is the protractor postulate, and that just says that every angle has a measure that is between 0 and 180, okay? So duh, that's common sense. Any angle will have a measure, okay? So anytime you think that, guys, if you think, duh, of course I know that, that is probably going to be a postulate. And so if you have a highlighter handy, guys, or if you just want to star these postulates, anytime in your textbook, anytime that we look at these, okay, I would highlight them or star them, because these are what we can use for what we call justifications. And we're going to look at how to use those in the next example. Okay. So let's look at example 1. Let's scroll down here. Example 1. So here we are proving the angle addition postulate. This is an example of a 2-column proof. And so this is what it's going to kind of look like on EOC. You will have a list of statements on the left side, and then on the right side here, you will have to figure out justifications, aka reasons, why each of the statements might be true. So at the top of that right column there, I want everyone to write justifications. Okay, because that's how they'll be addressed on EOC. So the angle addition postulate says, if we go back, it says all this here. Oh, crap. Angle addition postulate. What that means in layman's terms, okay? Simpler terms. If I add a little piece of an angle, and I add that to the other little piece of an angle, all that is going to equal the total big angle. Okay, so in simpler terms, that is the angle addition postulate. And you know, that's kind of common sense, right? If I add two little pieces together, it's going to give me the total. But here we're going to prove why that might be true. All right. So just bear with me, guys. Follow along. Fill in the blanks as I fill them in as well. But this is how you might approach a proof on end of course, okay? So I'm going to look at my first statement. It says the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, that is going to equal the measure of angle ABC. So this entire angle here, okay? So whenever I do proofs, I'm going to read my statement and think to myself, okay, why might that be true? What's something here in my justifications or reasons that I could use to prove my first statement true? All right. So what this says is if I add my little pieces together, it's going to equal the total. So that should sound familiar, right? We just talked about that. That is going to be the angle addition postulate. If I add all the little angles, they're going to equal that total. So that's the reason why statement 1 is true. Okay. Now let's go on to statement 2. So I went from statement 1 to statement 2 and some things have changed, right? We changed the measure of angle 1 into 23, the measure of angle 2 to 90, the measure of angle ABC to 131, okay? And the reason that we could do that, in our question here, they have given us all that information, okay? So because of that, also angle 2, they gave us right here with that symbol. But because I know that information, I can replace these symbols for their actual angle measure. So anytime that we replace things, guys, that's going to be the substitution property, okay? Think about it, with me and Mr. Bunshoe. Mr. Bunshoe is my sub, right? He is replacing me for the time being. So anytime you replace things of equal measure, that will be the substitution property. Okay. Now, likewise, if we simplify things, you are technically working with equal values, right? So if I added 23 and 90, it gave me 113. So what I've done is I've replaced this larger representation of that number for something simpler, aka 113. So I've simplified, I've replaced it for its simpler value. So that is also a case of substitution. Okay. Now, moving on to the next statement. So I'm not really replacing anything. In fact, it looks like something has been included or added. For some reason, they have subtracted 113 from both sides. Okay? The end goal here, they want to get measure of angle 3 all by itself. So that's the reasoning behind it. They're subtracting 113 degrees because you have a positive 113 degrees on the left-hand side. So because of that, I have subtracted something. So that is going to be the subtraction property. Okay. Again, guys, always ask yourself, why is this true? Or ask yourself, what is happening? Okay. Now, my last statement says the measure of angle 3 equals 118. Well, I've gone from this equation and simplified it to this final equation here. Again, anytime that I simplify things and replace something for a simpler representation, that's going to be another case of, substitution. And voila, you have completed your very first proof. But that's kind of what it's going to be like on EOC, guys. You will have to go through all of the statements, and on the right-hand side, you will have to provide all of the justifications. Okay. Okay, so turning to the next page here, we're not completing proofs, but we are using the previous theorems and postulates that we saw on the previous page. We're going to use those to help us solve, okay? So the first check problem, it says, what is the measure of angle 3 if angle 2 is 26? And then they've already told us angle 1, right? That symbol means 90 degrees. So I'm using the fact, if I add all of them together, I know they're going to equal the total, okay? So that would be an example of your angle addition postulate. And that can be helpful in finding angle 3, right? If I know the total should equal 180 because it's a line, I know one angle is 90, one angle is 26, and I don't know that third. That's the equation that you would set up to solve. And so when I take away the values that I know, if I take away 90 and 26, I'm going to be left with x is equal to 64 degrees. Okay, but that's an example of angle addition postulate in action. Okay. Let's see. You could also call that the complement theorem. So if you go back to page 197, they mentioned the complement theorem, but you guys should know what that is, right? Complementary angles equal 90 degrees. Okay. Let's look at the next problem here. So the next part of the check says, what is the measure of angle 4 if angle 5 equals 2x and angle 4 equals x plus 9? So 4 and 5, those two angles together form a line. So a theorem that we could use to support our reasoning would be the supplement theorem. Because again, supplementary angles equal 180 degrees. Okay, you could also say the angle addition postulate as well. But from here to solve, we add our values. We're going to set it equal to 180 because they form that line there. And then solve for x. So that's going to be 3x and 9 equals 180. If I take away 9 from both sides, that's going to be 3x equals 171. And x equals 57. Now they wanted us to find the measure of angle 4. So we just have to make sure to plug that 57 back in. So 57 plus 9 gives us 66 degrees. Okay, so on these future problems, guys, just be thinking and going back. One, I want you guys to work on solving the problem, but also I want you to include a theorem or a postulate that supports your reasoning, okay? So let's go down here. Example 2. So here is an example of using the complement and supplement theorem as well. All right. They've given us a word problem, but they've already laid out these statements step by step. And here are some reasons or justifications that we need to choose from. So we're going to look at statement 1. It says the measure of angle 3 plus the measure of angle 4 equals 180. And if we go over here to the diagram, 3 and 4 are found right there. So we're asking ourselves, what's a reason? How do I know angle 3 and angle 4 equal 180? What type of angles might they be? Okay. So if we notice 3 and 4, they form a line. Okay. Lines will add up to 180 degrees. So I'm going to go over here to my reasons and find something that might talk about 180, might talk about lines, might talk about linear pairs, something along those lines. Okay. So the only one that I see here would be supplement theorem. Supplementary means 180, okay, when two angles are added together. So that would be a justification. The supplement theorem. All right, so the next statement says 55 plus angle 4 equals 180. So the only thing that we've changed, the only thing that we've replaced is angle 3, and we have replaced it with 55. Okay, again, when things are being replaced, that would be the substitution property. Okay, and last but not least, so here, you can maybe have two answers, right? I told you guys whenever things get simpler, you could use substitution, okay? Or we could also use something else. So if we go from statement 2 to statement 3, what's happened? How did I get the measure of angle 4 equals 125? What did I do? Okay. So hopefully you noticed, if it's a positive 55, if I subtract that from both sides, that is what gives me that measure of 125 degrees. So for this statement, you could say either substitution, because we are substituting one equation for something simpler, or you could say subtraction. I would probably take both. Okay, so if you would like, go ahead and try the check on your own. One thing with proofs, guys, they get better with practice. Proofs are very, very, very difficult. I still struggle with some sometimes, so please do not beat yourself up about it. We're going to do a lot of practice with these, I promise. So I would go ahead and try the check on your own just to see how we're doing, okay? I will fill in the statements for you. So that second statement is going to look like that. So what I want you guys to do, I want you guys to pause the video, try to come up with the justifications on the right-hand side. And remember, guys, you are pulling from this word bank over here on the left. You guys will always have a word bank either on your tests if you're doing proofs. I will provide a word bank for you. Or on EOC, they will always have a word bank for those 2-column proofs. All right, so I'm looking at my first statement. It says the measure of BCA plus the measure of ACD equals 180. So again, when I add things together and they equal 180, that is going to be the supplement theorem, because supplementary angles equal 180. Okay. Now, when I went from the first statement to the second, if you notice, we have replaced ACD with 45 degrees because they told us its measure up here in the problem. So I've replaced things that are of equal value. So that would be the substitution property. And then the final reason or justification, I went from the second statement to the third statement by subtracting 45, right? If I subtract 45 from both sides, that's how I turned that 180 into a 135 degrees. So you could say subtraction property, or I'm actually substituting a more complex equation in the second statement for something simpler of equal value, okay? So I would take substitution as well, either or. Okay, so on the next page, we are talking about congruent angle properties. I want everybody to star this chart here because it talks about some very important properties that we use a lot. So the first one, reflexive property. And they've given us an example here. It says angle 1 is congruent to angle 1. With reflexive property, that just means something equals itself. Think about looking in the mirror, looking in a mirror and seeing your reflection. So you are looking at yourself. Something equals itself. So instead of angle 1 is congruent to angle 1, you could also say angle 3 is congruent to angle 3. Okay, they're exactly the same. Another example, you could say 4, just the value 4 is congruent to 4. But here is not an example of reflexive property. Let's say I had 2 by 2 is congruent to 4. So this would be a non-example because the reflexive property, guys, both sides of that equation have to look exactly the same regardless if they are of equal value, right? We know 2 times 2 does equal 4, but this is not an example of the reflexive property because it would have to be written identically on both sides. Identically. I cannot speak. I'm sorry. It's midnight. And I'm making this lesson for you guys, so I'm running out of words, okay? But reflexive has to look exactly the same, okay? Now, symmetric property. Our next one there, it says if angle 2 or angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. So all that is, if I have an original equation, I know that the flip of that equation is going to be true as well. So that is the symmetric property of congruence. Okay. Now, transitive property. That one is a little bit more tricky. So here it says if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. What that means is if I have 2 separate things, so if I have angle 1 and angle 3, notice they are both congruent to angle 2. So they're both congruent to that same angle. So because of that, they can be congruent to each other, okay? And so that's where they get that angle 1 is congruent to angle 3 from, okay? And so the reason these properties are so important, we use them a lot for justifications. So make a note here. So if you're ever filling in a 2-column proof or just a written proof, which we're going to see next, you can use these properties of angle congruence to fill in the blanks, okay? And so we'll see an example of that here in the proof of the symmetric property, all right? So we are proving that symmetric property. This is an example of a paragraph proof. We won't see much of those, honestly, guys, in EOC, but this one's a pretty simple one that you guys can definitely fill in, I think, okay? The first sentence says that we are given that. So with proofs, always start with given statements if you have one. In this case, we do. So we are given that angle J is congruent to angle K. By the definition of congruent angles, okay, so if I know these angles are congruent, I know that the measures of those angles will also be the same. So the measure of angle J will be congruent to the measure of angle K. And using the symmetric property of equality. So again, that symmetric property there, if we go back, let's see, I'll use green. If we go back there, it tells us if I'm given an equation, then I know the flip of that equation is also true. So here they said the measure of J is congruent to the measure of K, but the symmetric property will tell me the flip is true as well. So the measure of K will be congruent to the measure of angle J. And thus, those angles would be congruent. So angle K is congruent to angle J by the definition of congruent angles. So that's just an example of a paragraph proof, okay? I know a lot of these guys, it's kind of like, duh, like, why am I doing this? I already know this for a fact, but that's the point of proofs. We're trying to find every bit of evidence that we can to prove something is true, no matter how, like, common sense it might seem. Okay, we want to include every bit of evidence that we find. Okay, so we're going to skip over to example 4 on page 201. Okay, again, we are practicing filling in those justifications. They don't call them reasons anymore. I don't know why. They wanted to be complicated and turn over to justifications instead. But that's what they call them now, but it's the same thing. We're figuring out reasons why the statements might be true. So if we look at statement 1, they've already given us the justification. I know that this statement is true because it is found in the given statement. So if that ever happens, our reason, our justification can just say given, okay? So over to the side here, make a note. Always start with the givens. Okay, because that's just the, it's literally the information that you are given to start out with. So you always want to begin your proof that way. Okay. Statement 2 says angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. So we learned about those types of angles. We want to give a reason why that statement might be true. And I'm going to look here in my word bank. Okay. So I hope you noticed that those are examples of vertical angles. So the reason they're congruent would be the vertical angles theorem. Okay. Now moving on to statement 3. It says that angle 3 is congruent to angle 1. Let's look here. So before we have angle 1 is congruent to angle 3. Now we have angle 3 is congruent to angle 1. So what's happened there? They flipped, right? So whenever things are flipped, that is going to be the symmetric property of congruence. All right, our next statement I gave you, I said angle 3 is congruent to angle 2. So I'm trying to figure out a reason or a connection that angle 3 and angle 2 might have. Okay. So let's look here. Let's look at previous statement. All right, so if we look at the first statement here, it says that angle 1 is congruent to angle 2. And then my next statement says that angle 1 is also congruent to angle 3. Now, think back to your properties. If you need to, go back into your notes. We're looking for something that says if I have two different angles that equal the same thing, then they can be equal to each other. So here, angle 2 is equal to angle 1. Angle 3 is also equal to angle 1. So because they both equal the same thing, they both equal angle 1, that's how I can pull these to the side and set them equal to one another. And that's what we call the transitive property. Okay. All right, our last statement here says angle 3 is congruent to angle 4. So the only other time I see angle 4 is in this equation here. Angle 2 is congruent to angle 4. And now I'm going to try and find some connection that I established previously that connects angle 3 and angle 4 together. Let's look at statement 4 here. It says angle 3 is congruent to angle 2. So we know angle 4 is congruent to angle 2. Angle 3 is also congruent to angle 2. So I've got two separate angles that are equal to the same value. So for that reason, they can be equal to each other. And again, that's an example of the transitive property of equality. All right, again, guys, if you'd like to, go ahead and try the check on your own. Remember, you're just filling in the blanks, and you are using this word bank right here to help you find justifications. Okay? So number 2, the first statement actually is already given, right? We know this is true because it is found in our given statement, and so that one is done for us. Now on to statement 2. It says angle 5 is congruent to angle 4, and then angle 7 is congruent to angle 6. So think back to our previous lessons. What type of angles are those? Okay, hopefully you remember they are vertical angles. Okay, and so then that brings us to our next statement. It says angle 5 is congruent to angle 7. I have to figure out some way to prove that. Okay, if I look back at statement 1, it says angle 4 is congruent to angle 7. In statement 2, it says angle 5 is congruent to angle 4. All right. So if I know angle 7 equals angle 4, angle 5 equals angle 4, they both equal the same thing, so therefore they can definitely equal each other, and that is that transitive property. Okay. Now for our final statement. We're trying to figure out a reason why it might be true. And it says that angle 5 is congruent to angle 6. Well, the only other time I see angle 6 is in this statement here, so let's use that. It says angle 7 is congruent to angle 6. I also notice angle 5 is mentioned there. Let's use that. Okay. Hopefully you guys are catching on to the trend here. But angle 6 is congruent to angle 7. Angle 5 is also congruent to angle 7. So for that reason, those two angles can be equal to each other. And that is just another example of the transitive property. Okay, that's it for notes, guys. Whenever you get to your practice, what I want y'all to do, I'm only going to give you questions that ask you to solve. So like questions like number 1, it says find the measure of angle ABC, okay? So I want you to not only solve, but what I want you to do is go back into your textbook and include a reason. Find maybe a postulate, a theorem, anything at all that we have highlighted, or a property, okay? Anything that you might could use to prove why your equation is correct, okay? So not only solve, but also include a justification for each of your equations, okay? If you can't find one, that's okay. Maybe talk to your neighbors about some justifications they used, okay? And some might have several different answers. As long as you can prove to me a reason why your equation is correct, it will work. That will be fine, okay? Thank you guys for watching. This was a very hard lesson, so like I said, practice makes perfect. Hang in there, guys.